activity, we want to find the values of k for which the system of simultaneous equations kx minus 3y equals k minus 1 and 10x minus k plus 1y equals 8. Now we want to find the values of k for which there is a unique solution, an infinite number of solutions, and also for no solutions. Now, the little bit of theory behind all this is that for a unique solution, the two straight lines intersect in a single unique point. In other words, the two straight lines have a different gradient. For an infinite number of solutions, the two straight lines are in fact the same straight line, and therefore the gradients are the same, and also the y-intercept is also the same. For no solution, we want the lines to be parallel, but have a different y-intercept. Okay? Alright, so let's try this problem out. On a calculator page, what I'm going to do is I'm going to type in the equations, but since I'm going to reuse them, I'm in fact going to store them. So I'm going to store EQ1 as assigned equal to the first equation, and that was k times x. Now it is very important that you put in the k times the x there, otherwise it thinks that kx is the one variable. So minus 3 times y. We probably don't need the multiply sign there, but it's a good idea to put it in anyway. So that's equation 1 stored. I'll do a similar thing by typing in EQ2 is assigned equal to 10 times x minus, we need a bracket here, for k plus 1 times y equals 8. So now we've stored both the equations. Alright, so for the first equation I want to find the gradient. So what I can do is I can just do a menu, algebra, solve. So what I want to do is I want to solve the first equation, EQ1. Notice that it's bold because it's stored. I want to find that for y. So that gives me y equals. We'll do a similar thing for equation 2. I can just press up arrow and press enter, and that will paste equation 2 in, and all I have to do is change EQ1 to EQ2. Okay, so we can see that the gradient of the first line is kx over 3, so the gradient is k over 3. So we want to find when these values have the same gradient. So the first one has a gradient of k over 3, and the second one has a gradient of 2 times 5, which is 10 over k plus 1. So I'll put in a template here for 10 over k plus 1. Alright, so nothing's going to happen there. So what I want to do is I want to solve that equation for k. So menu, algebra, solve. Let's solve that equation. Rather than retype it again, I just press the up arrow, and I want to solve that for k. Okay, so that gives me my two critical values of k equals 5 or k equals minus 6. Now, one of them may give me no solution, one of them may be giving me an infinite number of solutions. We don't know which or what. Sometimes one gives me infinite number and one gives me no solution, but we can't really be sure about that, so we better check them all out. So what I'm going to do now is going to do menu, algebra, and now I want to solve a system of equations, option number 7 here. Option number 2 is solve system of linear equations. Now, it's prompting me for two equations, and the variables are x and y, so we'll tab to OK and press enter. So here it's asking me to type in the first equation. Well, I could type in the first equation, but I've already stored it. So let's just press the var command, and there we can type in EQ1, press the down arrow, and press the var command again, and this time I'll press the down arrow again to choose EQ2. So that's the advantage of typing in the equations and storing them, that I reuse them often and I don't have to type them in again. Alright, so we see that we've got a denominator there of k plus 6. So that's suggesting that when k is minus 6, there's no solution. We can confirm that by pressing the up arrow key and reissuing this command. But this time I'm now going to use the given command. So I'm going to press Control equals and press the right arrow and the down arrow to use the given or the with symbol. So now I'll type in k equals minus 6. So what will the computer spit back at me? It says it's got no solution found. So there's no solution when k is minus 6. Alright, let's have a look and reissue that command again. Press the up arrow twice. But this time I'll change from k equals minus 6 to k equals 5. So this time we get the solution in terms of this parameter C1. And what that's telling us is that there is an infinite number of solutions. Y can be any variable C1. X is 3C1 plus 4 over 5. So in summary, no solution when k is minus 6, but an infinite number of solutions when k is equal to 5. Now also, there is therefore a unique solution when k is not negative 6 and when k is not equal to 5. Alright, let's have a look at graphically, because often it's a good idea to link the graphical aspect and the calculator page as well. So let me define a function to be graphed, which is the straight line function. So menu, actions, define. If I want to graph a function, even a straight line in this particular case, we have to call it f1 of x. Now we've already transposed this equation to get y equals, so let's just go up and find where we had that one. That was the first equation, there it is there, f1 of x equals y. So if I press enter, that will paste that in, but what I have to do is I have to get rid of this y equals there. So that's f1. We can do a similar thing for f2. So menu, actions, define. And I'll type in f2 of x, and I'll go up and get the second equation, which was solved for y, which was that one. Once again, all we have to do is delete the y equals there. Okay, so they're my two equations defined. What I want to do now is graph them. So if I press the on key, and now I'll go down and choose a calculator page. Now one of the nice features about TI-nspire, the latest versions now, is that when we type in a function with a parameter such as k in there, it will automatically ask us to create a slider for the value of k. And I'll say yes for this one. Alright, we have to press tab again to graph the value of f1. So there's f1 and f2. We can move these labels out of the way. Unfortunately, they both came up in black. We can always change the color by doing a control menu and change the line color to one of the other graphs to say red. But the important thing here is that we want to look at the values of k equals, 5 and negative 6. Unfortunately, our slider has only got from negative 5 to 5 here. So what I want to do is I want to move this slider out of the way a little bit, and I'll move it just down here, and I'll also change the settings so that we can see that k is going to go to at least say negative 7, and we'll say up to say 7 as well. And we'll say in a step size of 1, but that's fine. So we'll just click on OK. Now we see that the two straight lines intersect in a unique point when k is equal to -1, but when I change the value of k now, so we'll see what happens when k is equal to 6. So when k is equal to 5, that was our critical value. So there we can see when k is equal to 5, the two straight lines are the same straight line, in which case there is an infinite number of solutions. But let's just check out the other value when k is equal to -6. There, we see when k is equal to -6, the two straight lines are parallel, and therefore there is no point of intersection, in which case there is no solution. So I think this little example illustrates the graphical technique of solving these type of simultaneous equations, and also the calculator page as well.